I want to teach you a strategy for factoring quadratic polynomials by using a method called grouping. Now usually grouping is introduced with cubic polynomials like the one that I've shown here, x cubed minus 4x squared plus 3x minus 12. The idea of grouping is to put two terms together. So for example, the x cubed minus the 4x squared and the other terms together, for example, 3x minus 12, and look for common factors. So the common factor out of x cubed minus 4x squared is x squared. So we'll factor it out. And we're left with x from the x cubed term and minus 4 from the minus 4x squared term. Then I'll look at the other group, 3x minus 12, and I see that it has a common factor of 3. So let's factor the 3 out, and I'm left with 3 times x minus 4. Now the strategy of factoring by grouping takes advantage of the fact that x minus 4 is now a common factor of the two groups. So if I factor the common factor out, I like to factor it to the right, it doesn't matter. I'm left with x squared from the first group and plus 3 from the second group. And so this is my factorization. This cubic factors into x squared plus 3 times x minus 4. Sometimes this quadratic piece can be factored further, but in our example it can't. So now, let's look at how to use this strategy of grouping to factor a quadratic. If I want to factor the polynomial x squared minus 11x minus 60, and I want to use grouping, there are three terms, so I don't know how to group it. Now the strategy is we're going to introduce four terms by splitting 11x into two pieces. And the way that we find those two pieces is I look at the leading coefficient times the constant term, and in our case that's 1 times negative 60, which is negative 60. And I'm going to look for all of the factors of negative 60. So we already have 1 times negative 60, 2 times negative 30, 3 times negative 20, 4 times negative 15, 5 times negative 12, 6 times negative 10, and then I start going back the other direction. 10 times negative 6. And so I'll work my way back up so that all these negatives become my positive terms. Now, I'm not going to write down that entire list. I want to look for factors so that when you add them, you get negative 11. So as I look down, 4 times negative 15 is negative 60, but when you add them, you get negative 11. And so you split that 11x, minus 11x, into 4x minus 15x, and now you're able to group. So x squared plus 4x, factor out the x, and I'm left with x times x plus 4. For my other terms, I always want to factor out that full coefficient, so minus 15 times x plus 4. And now x plus 4 is a common factor. X plus 4 times x minus 15. And I've just found the factorization of the quadratic by using grouping. The same strategy of grouping works for more complicated examples. For example, 6x squared plus 19x minus 20. I'm going to do the same thing. I want to split 19x into two pieces. And those two pieces are going to be found by looking at the factors of 6 times negative 20 which is negative 120. So I want to look at all the factors of negative 120 and find some that add to 19. So I get 1 times negative 120, 2 times negative 60, 3 times negative 40, 4 times negative 30, 5 times negative 24, 6 times negative 20, 10, so can I do 8? 8 times negative 15, 10 times negative 12, and then I start going back in the other order. I'm looking for some that add to 19. So let's see. Here I get negative 19, and so I'm going to reverse the signs, and I get 6x squared minus 5x plus 24x minus 20. And now I'm going to pull out common factors. I group, and I get a factor of x, 6x minus 5, and here I get a factor of 4. So plus 4, 6x minus 5. 6x minus 5 is a common factor. I can break it out. 6x minus 5 times x plus 4. And so I've used grouping again to help me factor that quadratic. All it requires is that you know how to find the integer factors of the product of the first and the last terms in the quadratic, and then look for the terms that add to your x term. Now I just realized there's a special case that I didn't take into account. So let me show you. Consider the following example. 6x squared minus 11x plus 5. If I take my leading term and my constant term, I get the value 30. So let's start creating a list of all the factors.
1 times 30, 2 times 15, 3 times 10, 5 times 6.
And then 6 times 5, 10 times 3, 15 times 2, and 30 by 1. And I'm looking for things that add to negative 11. Now, 5 plus 6 equals 11. So what I need to remember is whenever I have positive value like 30, that not only do I have the factors that are all positive, I have the same factors that are both negative. So my negative 11x splits into two terms, both of which are negative. 6x squared minus 5x minus 6x plus 5. And now I can do my grouping. 6x squared minus 5x has a common factor of x. Minus 6x plus 5 doesn't look like it has any common factors. But at least I want to factor out that negative sign. Because notice if I factor it out, I'll get my 6x, and instead of plus 5, I'll get minus 5. Without that step, I wouldn't have seen this common factor 6x minus 5. So I factored out 6x minus 5, and I'm left with x minus 1. Now I have a question for you. What would happen if I wrote my split in a different way? What would happen with the factoring? I'll let you find the answer. All right, so that's a way to find factors of quadratics using the method of grouping.